Chapter 10, Section 5, Trigonometry and Area.
Recap on SOHCAHTOA. Sine equals opposite over hypotenuse. The function of cosine is adjacent over hypotenuse. The function of tangent is opposite over adjacent. Remember, this only applies for right triangles. The side across from the given angle is the opposite leg. The longest side touching the angle is called the hypotenuse. The side touching, or the other leg, is called the adjacent leg. An easy way to remember sine, cosine, and tangent is by the acronym SOHCAHTOA. SO, or SOH, stands for sine, and that is opposite over hypotenuse. CAH, or CA, stands for cosine, and that is adjacent over hypotenuse. TOA, or TOA, stands for tangent, and that is opposite over adjacent. This is a general overview of SOHCAHTOA, or sine, cosine, tangent. So working off of this triangle, the hypotenuse measure is 13, the adjacent measure is 5, and the opposite leg measure is 12. And working off of angle x, the triangle sine would be 12 over 13 because it's opposite over hypotenuse. The cosine would be 5 over 13 because it is adjacent over hypotenuse. And the tangent would be 12 over 5 because it's opposite over adjacent. The adjacent leg is x, and the hypotenuse is 14, and we're trying to figure out the cosine of the angle of 37. Cosine of 37 equals x over 14. Leave it. And then you do cosine times 37. Bring over the 14, so times the whole thing by 14. And then you have 14 cosine 37 equals x. And then you use a calculator to figure out the answer. The answer is x equals 11.18. So here we have a recap of special triangles. Special triangles are 45 degrees, and 90 degrees, which is isosceles, and then there's 30 and 60 and 90. For the isosceles 45, 90, there's two sides that are the same, and the hypotenuse is a root 2. So in this example, it's a 45, 90 triangle, and the hypotenuse is 18, and we're trying to get y. So you do 18 over root 2 because the hypotenuse is a root 2, and so the answer is 9 root 2. So here we have a 30, 60, 90 triangle. The base is a, and the hypotenuse is 2a. Now the other adjacent side is a root 3. So here we have an example of a 30, 60, 90 triangle, and we're trying to find x, and the hypotenuse is 36, and the adjacent is 18 root 3. So we have to do x equals 36 over 2, and that equals 18. Okay, so here we have an octagon, and the center point is C, and we are trying to find the area of this. So first we're going to start to split it up into right triangles, as many as we have to for all of them to be right triangles. And then we have to find the area of that triangle and multiply it by the number of triangles inside. So this angle is 22.5 degrees. And then we don't know what the adjacent is, so that's A. And then the hypotenuse is 16.2. So here we have me splitting up the polygon into multiple right triangles. And there's 16 right triangles. So you have to split the shape into multiple right triangles and then find the area of each triangle in the octagon. And then you have to multiply by the number of triangles in the octagon to find the area. So there's 16, so you find the area of one of them and then times that by 16 to find the area of the octagon. Okay, so here we have cosine 22.5 equals A over 16.2. And then you have to multiply the whole thing by 16.2, and then cosine 22.5. And then you have to use a calculator to get the answer. And this is me showing what the small triangle looks like. You have 90 degrees, and then you have 16.2, 22.5 degrees. And we're trying to find the area. So the area is 14.97. So it's sine 22.5 equals x over 16.25. X over 16.2. And then you bring it over and multiply that, the whole thing, to get x. And then you use a calculator and do 16.2 sine times 22.5 equals x. And then the answer is 6.2. So here we have how you get the area of the whole shape. So you have area equals base times height divided by 2 to get the area of the triangle. Then you have area equals 6.2 times 14.97 divided by 2. Then you have 46.41 times 16. That's the number of right triangles, and to find the area of the whole polygon, that's what you do. The area of the polygon is 742.56. The Pentagon is the largest office building in Virginia. It's a regular pentagon, and each side length is 922 feet. Find the area of the land that the Pentagon covers. So first off, we need to split up the polygon into many right triangles. And since it's a pentagon, so it has 5 sides, there's going to be 10 right triangles. And then we'll have to multiply by the number of triangles to get the area. So here we have 10 right triangles. And it's going to be 360 divided by 5 to get 72. And then divided by 2 to get 36 degrees. And each side length is 921, so divide by 2. And that equals x, and that's going to be 460 degrees. And then, yep, the angle's going to be 36 degrees. So here we have a triangle, and we're trying to find x, and we have the opposite side, and the adjacent is x. So we're doing tangent, so it'd be tangent 36.25 equals 460.5 divided by x, and then you move tangent underneath 460.5 to divide, and then you get x equals 622.33. So that is the adjacent leg. So now you have to find the area of the triangle. So you have to do 1/2 times 622.33 times 460.5, and the answer is 100,443, 291.49, and that's the area of the triangle. So now that we have the area of the right triangle, we have to times that by 10 because there's 10 right triangles. So that'd be 100,043, 291.49 times 10, and that's 1,432,914.9 feet squared, and that's the area of the pentagon.